Today we are going to discuss electric flux and Gauss law problems. First problem, total electric flux coming out of a unit positive charge put in air. So solution, total flux coming out from unit charge flux is equal to E bar dot S bar is equal to Q upon epsilon naught. That should be equal 1 by epsilon naught. Q charge value 1, so 1 by epsilon naught. It means that flux is equal to epsilon inverse. This is the answer to the question. Next model. In a region, intensity of an electric field is given by E bar is equal to I cap plus 3J cap plus K cap Newton for Coulomb. The electric flux through a surface S bar is equal to 10 I cap meter square in the region is. So what they are asking here, flux phi is equal to E bar dot S bar. E bar value they given 2 I cap plus 3 J cap plus K cap in dot S nothing but 10 I cap. So here the Newton for Coulomb, here the meter square. So here dot product nothing but I dot I only exist, J dot J only exist, K dot K only exist, remaining all are 0. So here I dot I only exist, 2 into 10 I dot I 1 into Newton meter square per Coulomb. It means 20 Newton meter square per Coulomb. This is the answer to the question. So another model, a charge 10 microcoulomb is placed at the center of a hemisphere of radius r is equal to 10 centimeter as shown in figure. The electric flux through the hemisphere is. So according to Gauss law, electric flux through sphere Q upon epsilon naught. So electric flux through hemisphere 1 by 2 Q upon epsilon naught. So they are asking hemisphere. So hemisphere flux is equal to 1 by 2 Q upon epsilon naught. That should be is equal to 1 by 2 Q value 10 microcoulomb, nothing but 10 into 10 to power minus 6 divided by epsilon naught value constant 8.84 into 10 to the power minus 12. So simplify, flux is equal to, so we'll get the, after simplification we'll get the 0.56 into 10 to the power of 6 Newton meter square per Coulomb, approximately 0.6 into 10 to the power minus 6 Newton meter square per Coulomb. So or 6 into 10 to the power of 5 Newton meter square per Coulomb. This is the answer to the question. Now another question, electric charge is uniformly distributed along a long straight wire of radius 1 mm the charge per centimeter length of the void is q coulomb. Another cylindrical surface of radius 50 centimeter and length 1 meter symmetrically enclosed the void as shown in the figure. The total electric flux passing through cylindrical surface is. So charge enclosed by cylindrical surface. Here this surface length of the cylinder 1 meter, nothing but 100 centimeter. The charge should be is equal to enclosed charge. Closed charge should be is equal to 100 centimeter into charge. Total charge already they given. The charge per centimeter length of the wire is q coulomb. They given. So according to Gauss law, so flux is equal to q enclosed upon epsilon naught. So q enclosed nothing but 100 q. So 100 q divided by epsilon naught. This is the answer to the question. Another model, a sphere of radius capital R has a volume density of charge rho is equal to kr, where r is the small r is the distance from the center of the sphere and k is the constant. The magnitude of the electric field which is exists at the surface of the sphere is given by epsilon naught, nothing but permittivity of free space. So here according to Gauss law, flux is equal to integral of e bar dot dx or ds bar, or that should be is equal to uniform electric field into area e bar dot is equal to q enclosed divided by epsilon naught. So electric field into area is nothing but 4 pi r square. That should be equal to q enclosed. Charge nothing but volume density into area into length. So charge density into volume. So here rho into 4 pi r square into dr divided by epsilon naught integral, because very small elemental charge here. So electric field E into 4 pi, you may write here capital R square should be is equal to integral limits here 0 to capital R. So rho value is nothing but k into small r into 4 pi r square dr divided by epsilon naught integral 0 to r. So electric field into 4 pi capital R square is equal to 4 pi k, you may write out of the integral because constant 0 to capital R into r cube into dr divided by epsilon naught. 4 pi get cancelled. So electric field into r square is equal to k upon epsilon naught into integral r cube nothing into dr nothing but r power 4 by 4 limits 0 to r. So substitute this limits, higher limit minus lower limit. Electric field into r square is equal to k upon epsilon naught into capital R power 4 divided by 4. So this r square and this square get cancelled. So electric field is equal to k capital R square by 4 epsilon naught. This is the answer to the question. Now another model, the inward and outward electric flux for a closed surface in units of Newton meter square per coulomb are separately 8 into 10 to the power of 3 and 4 into 10 to the power of 3. It means inward 8 into 10 to the power of 3, outward flux 4 into 10 to the power of 3. Then the total charge inside surface is, where epsilon not nothing but permittivity of free space. Solution. What they asking here? Then the total charge, total enclosed charge they asking. According to Gauss law, so flux should be is equal to Q enclosed by epsilon naught. So enclosed charge should be is equal to epsilon naught into flux. That should be is equal to, here the change in flux. So total flux, epsilon naught into total flux. Inward flux minus outward flux positive, already I said, minus 8 into 10 to cube plus 4 into 10 cube. So total Q enclosed is equal to 4 minus 8 minus 4 into 10 cube epsilon naught coulombs. This is the answer to the question. Now another model, the electric flux for Gaussian surface capital A that enclose the charged particle in free surface. So Q1 is equal to minus 14 nanocoulomb, Q2 is equal to 78.85 nanocoulomb, Q3 is equal to minus 56 nanocoulomb. So what they are asking? Total flux. So total flux, which Gaussian surface? A Gaussian surface. So solution. So see the diagram. This one is a Gaussian surface. So flux is equal to Q enclosed upon epsilon naught. Q enclosed nothing but sum of total charges. One is the minus 14 into 10 to the power of minus 19 plus 78.85 into 10 to the power of minus 19 plus into minus 56 into 10 to the power of minus 9 coulomb upon epsilon naught. Epsilon naught value 8.85 into 10 to the power of minus 12. That flux should be equal to minus 14 minus 56 minus 70 into 10 to the power of minus 9 plus 78.85 into 10 to the power of minus 9 all divided by 8.85 into 10 to the power of minus 12. So flux is equal to 78.85 minus 70 nothing but 8.85 into 10 to the power of minus 19 divided by 8.85 into 10 to the power of minus 12. Here the plus 12. So here the 1 that should be is equal to approximately 10 cube. It means flux should be is equal to 1000, that should be is equal to 10 cube Newton meter square for coulomb. This is the answer to the question. Another model, a hollow cylinder has a charge q coulomb within it. If pi is the electric flux in units of voltmeter associated with the curved surface B, the flux linked with the plane surface A in units of voltmeter. So this is showing the figure. According to Gauss law, electric flux is equal to total flux. Electric flux total nothing but so flux on A area plus flux on B area plus flux on C area should be equal to Q enclosed by epsilon naught. that should be equal to q upon epsilon naught. So qa value we don't know, qc value we don't know. They are asking a, for example. So here according to question, so flux at B is equal to the given phi. Assume flux A should be is equal to B because this area same. So and the radius also same. C is equal, let us consider pi dash. So these two values substitute here. Total flux is equal to here pi dash plus pi dash is equal to q upon epsilon naught. 2 pi dash plus pi is equal to q upon epsilon naught. So 2 pi dash is equal to q upon epsilon naught minus pi. Pi dash is equal to 1 by 2 of q upon epsilon naught minus pi. This is the answer to the question. Now another one, a point charge causes an electric flux of minus 10.0 into 10 to the power of plus 3 Newton meters per coulomb to pass through a spherical Gaussian surface of 10.0 centimeter. Radius centered on the charge. If the radius of the Gaussian surface were 3 times, how much flux would pass through the surface? Solution: according to Gauss law, flux is equal to q enclosed upon epsilon naught. This value should be equal to the given minus 1.0 into 10 to the power of 3 Newton meters per coulomb. But here the independent of the radius, here 3 times the surface, 3 times independent of the radius, whether decreasing or increasing radius, but in Gaussian surface this flux independent of the radius, directly proportional to enclosed charge only. So independent of the radius, that's why flux remaining constant to minus 1.0 into 10 to the power 3 Newton meters per coulomb, remaining constant. This is the answer to the question. Another model, an infinitely long thin straight wire has uniform linear charge density of 1 by 3 coulomb per meter. Then the magnitude of the electric intensity at a point 18 centimeters away is. So according to question, what they asking here, electric field is equal to how much? They given lambda is equal to 1 by 3 say coulomb per meter. Coulomb per meter is one dimensional. Long wire nothing but one dimensional. This will look like a, this is a long wire. This one is one long wire. Here you may draw the Gaussian surface and it look like a, cylinder. This length, let us consider L. This radius here to here, this is center. This point to here, this small r. So according to Gauss law, flux is equal to integral of E dot ds bar should be is equal to q enclosed by epsilon naught. Q enclosed by epsilon naught. Q enclosed charge, let us consider Q. So flux or integral of E bar dot ds bar is equal to Q upon epsilon naught. Electric field uniform electric integral ds is equal to Q by epsilon naught. Integral ds nothing but area of this cylindrical Gaussian surface into 2 pi r into L is equal to Q by epsilon naught. Electric field is equal to Q by 2 pi epsilon naught r into L. This value Q divided by L divided by the whole divided 2 pi epsilon naught into r. Q by L nothing but lambda. So that electric field is equal to lambda charge per unit length, nothing but charge density, one dimension charge density by 2 pi epsilon naught r. So lambda value they given 1 by 3 and here 1 by 2. So here multiply and divided by 2 divided by 2. So we'll get the 4, we'll get the here pi epsilon naught r. So 4 pi epsilon naught r nothing but 9 into 10 to the power of 9. So that electric field is equal to 1 by 3 into these 2 into 9 into 10 to the power of 9 into r nothing but 18 centimeter, 18 into 10 to the power of minus 2. So 10 to the power of, so this 9 2s are 18. So 1 by 3 into 10 to the power of 11, approximately 0.33 into 10 to the power of plus 11 Newton per coulomb. This is the answer to the question. So electric field is equal to 0.33 into 10 to the power of 11 Newton per coulomb. Now this is the answer. The angle subtended by a circular disc of diameter 2 cm at a distance 1000 cm from your eye is, angle substance is nothing but a circular disc, nothing but solid angle denoted by letter omega like this, area by r square. Area is nothing but disc area pi r square by r square. Pi into r nothing but diameter 2 centimeter, r nothing but radius, diameter by 2 nothing but radius 1 centimeter whole square divided by 1000 centimeter whole square. That solid angle is equal to 3.14 into 1 centimeter square divided by 10 to the power of 6 into centimeter square get cancelled. 3.14 into 10 to the power of minus 6. This value converting in degrees, that should be is equal to 0.00018 degrees. So this is the answer to the question.